Hello there. We'll write a program to find the perfect numbers between 1 to n. Welcome to C programs lecture 2. Now, what is a perfect number? A perfect number is 1, wherein if you take a number n, when you take a number n or n, find divisors equal to, find divisors from 1 to less than n, and find the sum of those divisors if they are exactly dividing the number if the sum is equal to the number, then the number is a perfect number. Okay, pretty simple logic. So let me first accept as usual printf input equal to percentage %d. Okay, I'll say scanf percentage %d and of n. So I'll simply print the printf the perfect numbers from 0 from 1 to n are will generate the perfect number. Okay. So now if you look at this code, so I will first take for I equal to. Why am I using for loop? Because I know I am looping from 1 to n in advance. When we should use the while loop? Because I don't know how many times I loop. So I equal to I is less than n. I is less than n. Or equal to n to be precise, I plus plus. So each number will find out whether it is a perfect number or not. So for that, I need a sum because I am supposed to calculate the intermediate sum. So my sum will now be equal to int sum equal to 0. Now what I have to do is I am supposed to find the divisors. To find the divisors, first I will create a temporary variable called temp, which I will initialize it to I. While my temp remains less than I, I'll start my temp equal to 1 not I. So my remains less than I. So here I don't know how many times I am going to loop, right? So what I will do is I will take the number. Okay, I'll take sum is equal to sum of sum plus. Now I have I, correct? Then I'll do mod temp. I mod temp, whatever is the value of temp. So I'm simply if if it is equal to 0, isn't it? So that is the condition that we are supposed to take. So if my I mod temp is equal to 0, then my sum is equal to sum plus that divisor, because it is dividing. So my temp is equal to temp plus 1. I'll move to the next divisor. The issue there is, suppose if I do less than or equal to, the number is divisible by itself. So that doesn't become a one of the divisors for perfect number. So it has to be less than n, less than that number. Okay. So here, before I before I move out, before I go to the next index of the loop, I'm still within this loop. So just to be, I am in this loop, if you see. So what I'll do here is I will say my, if the sum that I have found out is equal to I, means that I is a perfect number. So I'll simply say printf percentage d comma space comma I. Hopefully this code should work. Let us see. We have given temp, we also have to give sum is equal to 0. Alright, so once I do that, after again my sum has to become 0, otherwise my sum will keep on, right, retaining the previous one. So my sum is 0 again back. Alright, so let me save this as we are doing perfect pn.c. So let us go back and do the GCC of pn.c. pn.c. We have I think I has to be declared. Let me also declare I. Did we declare n? We'll declare n as well. Okay, so we'll save this code. Okay, fine. So we'll have an OP. Okay, so here again we have a problem like similar last time. So we just do this, save it. Okay, Control C. So if I now do the so let me just from 1 to 10, let me see how many perfect numbers are there. There are only 6 is a perfect number, isn't it? According to our explanation as well. Just out of curiosity, let's just find out how many perfect numbers are there between 500 and 1 and 500. Only 3. 6 is 1. Now how is 28? So 20, if you take 1 by 1 to 27, so 1, then 2 is also there. Okay, so 2 is also a perfect divisor. Then 3 is not a perfect divisor. 4 is a perfect divisor. So 4 7 is 28. Then we have 5 is not, 6 is not, 7 4, so 7 is also there. 7 4 is 28. 7, then we don't have 8 9 10. I think we must be having 14 if I am correct. Alright, so 14, after that nothing. So 14 plus 7 is 21, 21 plus 7 is 28. So this is a perfect number. Right, so let us see how many are there between 1 and say 9,000, 90,000. There are only now 4. Now it just grows, the time grows in some order, which your algorithms teacher may teach you later. So it is going to take a lot of time, right? But we still have 8128, wherein the divisors of from 1 to 8127 will get back as 8128. So let us see what are these divisors. So just out of curiosity, we had this sum. So if we can get if I can store the divisors as well and print the divisor. So for that, I don't know how many divisors will I get. So if I can store that in an array, it is just out of. So let me go declare a div array. So maybe I may get a maximum of 50 divisors. Okay. So what I may do is I will have uh, so the divisors would be just to my div of temp, whatever is the divisor, if it is exactly divisible, so I will just put that in the array. Just later I want to find out whether we are getting the exact divisors. This has nothing to do with the problem, but always we are curious enough to understand what it actually means. So div of say temp is equal to that divisor itself. Is it what we are doing? So uh, correct. So my if my temp is div of 1, so if it is not divisible, then the divisor won't be a part. So my it will be from end 1 to end. So let me just see. So the divisors of that number now. We'll just display its divisors just to see. The divisors of perfect number, say percentage d, which is nothing but I, or so we have for we'll have int k for k is equal to 1, k less than temp, k is equal to 0, k less than temp, k plus plus. So I will display those values, which is my divisor of k. So that this works fine. Just curious to know the divisors, of course. So bracket we have forgotten. Okay, I think this one here. Okay, let me save this code. Okay, let me give the OP and let me give you 6. So divisors are 0, 1, 2, 3. Oh, are we getting a problem here? Maybe here. So if the temp is equal to 0, so my okay, I'll have one more called j equal to 0. So I'll only put the value of j, increment the value of j. So that's fine. So I will say less than j. and then I'll get this is k is fine. I'll also make j again as 0. Okay, so if I will say up to 10, so it's a perfect divisor of perfect number 6 are 1 2 3. So we will see what we got for 500. For 500 we got 3. So these are the divisors. Okay, 1 2 4 7 14, perfect. Now the divisors of perfect number 496 is 1 2 4 8. Oh God, all this if you add, they're all exactly dividing that. So the last one we look at is 10,000. See, so 8128, that's the perfect divisor. So next it just exponentially grows. Okay, not bad. So for 8128, so these are the uh, divisors that we are getting up to 4064, but this is still calculating. All right, so it becomes a very time complex problem. So it ended there. So I think it ended 8128 is the uh, perfect number that we got. So maybe another two zeros if I add. So it is ending at 8128. Let us wait for it. How long it is going to take. Okay, so fine. I think you can actually code on your own and then come back and see how exactly this code actually works. I request you to code on your own for you to become perfect. These are like mathematics. When you see them you'll understand, but when you actually try to solve you find it a little bit tricky. So hope you understood this lecture. The next in the coming lectures. Thank you very much.